Good evening and welcome to our session, Safeguarding the Power System, Investing for Resilience. I am a disaster risk management specialist at the Global Facility for Disaster Reduction and Recovery, GFDR, at the World Bank. My name is Natalia Romero and I will be moderating this session. In this session, we are going to hear perspectives from Bangladesh, Ukraine, and Japan on understanding risk and learning how to manage the risk for a resilient power system and service. We're going to go over the three presentations, and then at the end of those three presentations, we're going to have some time for questions and answers from all of you or comments. So to start, I'm going to invite Mr. Manzoor Hazarika, Director of the Geoinformatics Center at the Asian Institute of Technology. He and his team are simulating failure climate risks in Bangladesh to assess their impacts to the power system. Mr. Mansoor, the floor is yours.
Thank you. Good afternoon. So this project actually, we are working with World Bank, and just started the project, so we're still working on getting some data from the Bangladesh government side. Whatever we have done here, all using open source data. So AIT, where I work, is is the leading of this project, and also NCAR, National Center for Atmospheric Research in Colorado Boulder. They are our partner for climate part, and RTI International for the flood part. So this is basically, we know Bangladesh is very highly vulnerable for hydrometeorological hazards, particularly floods and cyclones. And power infrastructure and facilities exposed to flood and cyclone are highly sensitive to changes their frequencies, intensities because of climate change in next 50 to 100 years. And so what we are trying to do this risk assessment from cyclone and flood and how it will impact on this power infrastructure in Bangladesh, so that they can be government takes necessary mitigation measures in advance. So these are some of these disaster risk for flood and cyclone, storm surge, river, published by ADB in 2021. But this is a little bit of course kind of map, some index they have used. But we'll be doing a little bit more detail in high resolution. So objective of this study is to equip the government of Bangladesh and power sector agencies with the resources and facilities to facilitate asset and system level resilience planning and policy under uncertainty in the future climate scenario. And so for this, we will be looking at modeling for cyclone, flood, extreme weather events, and coastal inundation. And overlaying whatever hazard maps are coming, we overlay with the power infrastructure assets to look at the exposure. And then we conduct this, we'll also look at the vulnerability from different intensity of hazard, and we'll do the multi-hazard risk assessment, particularly mainly for cyclone and flood. So it has two components. So first component, we'll look at the flood hazard, wind hazard, and do the risk assessment. And in part two, component two, we'll also look at the future near, mid, and far-term scenario for these hazards. And we also overlay this information with the power system assets and to get their vulnerability and do the risk assessment. So this is very common, just to how we are going to do this. And basically, exposure and from hazard modeling, we'll get the weather and climate events. So for past historical data, we'll see how it has been, this flood and cyclone hazard. And then we also look at the future scenarios, 3 scenarios I have mentioned, how this will be changed in the next 50 to 100 years, and then we'll see how it will be affected. So for flood, for future scenarios, we are using some of these climate projections, using some ECMIP runoff resource products. And then also we are collecting river resource from the Bangladesh Water Development Board, and also historical cyclone data, and all goes to the platform called CLIMADA, which is a multi-hazard risk assessment platform developed by ETH Zurich. And also for flood modeling, we'll be using Kama Flood. This is a flood developed in University of Tokyo. It's open source. And then all these things also, like from the down below, element at risk of power system infrastructure, power plants, power lines, all those things will be going to this CLIMADA platform. So hazard map, then your exposure map, then your vulnerability information curves for these different assets we put together, and we get the loss and risk estimates finally. So this is historical flood simulations using Kama Flood. So whatever data openly available in open source, we simulate using this model. And you can also see these power plants, those red color dots, those are power plants which will be in Bangladesh existing power plants. And this is for SSP 126 for 2040 near term, 2070 mid term, and 2100 long term. And for you can see the flood maps, how it will be look like for this particular SSP scenario, and also this power plants locations. You can see how it will be affected. So those power plants which are exposed to the flood, we need to see how Bangladesh government can do something to protect them or mitigate the risk. And there's also some to large power plant in the downside, yellow color. Those are not exposed, actually. Those are in a high place somehow, so they are not really exposed to flood, but definitely they'll be exposed to cyclone. So this is for SSP 585 scenario, again 2040, 2070, and 2100. And this is the situation. This is a worst case scenario. And for cyclone, this is being done by ANCAR using SAS model. So for 2035 to 45, and 45 to 55, 55 to 65, how this kind of these are synthetic tracks, they call. So they made a simulation. So these are the some of the area where it will be highly concentrated of these future cyclones in Bangladesh. So also they have also, in 2007, Cyclone Cedar, it's one of the very big cyclone Bangladesh had in recent years. And they have made this simulation. And this is quite high resolution simulation. But also NCAR, they are using some techniques called PBL, planetary boundary layer. If you use that kind of technique, you can see this very detailed wind hazard map so that your power assets will be clearly you can mark in how it will be affected. So what we are thinking is that for wind, I think mostly power lines will be affected. Power plant will be, but mostly power lines will be affected. So how those are exposed to very high exposure and risk, then government should be able to make some mitigation measures. So this is the kind of wind intensity and the power plant exposure. Also, you can see the lines, the different colors. Those are lines, power lines. So opportunities. This study will generate information about the current and future flood and cyclone hazard and risks to the power infrastructure in Bangladesh. And the risks to the power infrastructure will be generated in geospatial in a map format, so the government can prioritize mitigation measures, and particularly those power plants or power assets highly exposed and high risk, they can take some mitigation measures. For example, if suppose some of the power lines are exposed in future, very high wind cyclone coming up, they can think of making those power cables in those locations underground, for example. Or some of the power plants are they'll be exposed to flood in future, so they can think of elevate them at this point of when they get this kind of analysis. So challenges, while climate and hazard modeling are done at national level, but risk assessment need to be done at the very high, at the building level, each power plants, right? So there's a kind of trade-off because your hazard maps are not so high resolution because of national level, whole country you are doing, but we are using. So we are trying to see how best we can solve this issue. Securing data is always a challenge in development. It's not only Bangladesh, or many of the countries, they have data, but it takes time, a lot of persuasion, a lot of other things. So I think we are going to get some data. Once this local data comes, I think this improvement will happen on these maps. Thank you.
Thank you, Mr. Masul. That was definitely a very enlightening presentation about that ongoing study in Bangladesh. Like I mentioned at the beginning, if you have any questions, please write them down or just keep them for the end of all the presentations. So next, we're gonna learn about the shocks faced by the power system in Ukraine. For that, we're gonna have two speakers. One is joining us here in person, and the second is joining us virtually. Here in person, we have my colleague, Mr. Koji Nishida, Senior Energy Specialist, who is currently leading an emergency project to support Ukraine's restoration of the transmission facilities. And then virtually, we have connected Mr. Oleg Pavlenko. He's the Chief Investment Officer at the national power company, Ukrenergo. So Koji-san, over to you.
So, yeah, good afternoon, everyone. My name is Koji Nishida. I'm a senior energy specialist with the World Bank. So I'm going to talk about Ukraine. The country, of course, has been in a very difficult situation. Of course, this is caused by man-made disasters, but there is similarity with the damages caused by natural and climate-related disasters. So we have lots of lessons learned from Ukraine. Of course, the situation is still ongoing. The World Bank has been supporting Ukraine, many aspects. One is this assessment on the damages and the needs for the reconstruction and the recovery. The bank estimates $486 billion of needs to restore damage to facilities, houses, roads, and energy facilities, of course. And which is the amount is very significant, three times of GDP, Ukraine GDP. So this is very, devastating situation. Energy sector is one of the most affected sectors. Particularly recently, many energy infrastructure, particularly power generation and power transmission facilities are damaged, targeted and damaged. So there are lots of transformers and generation plants have been, destroyed. The main target, from the military attacks has been on the power transformers, the large power transformers, which is critical in the stream of the electricity. And then the loss of these transformers caused significant bottleneck on the electricity supply, which caused supply restrictions. And there have been many regional and national-wide outages all over the country. So this is very, they know which element is significant, has most, for them efficient for the enemy side, which is what is the most efficient strategy for the attack. So they focused on the transformer, particularly in substation. As I said, the bank has been supporting Ukraine, providing both financial support and also technical assistance. From financial perspective, we provided almost 400 million US dollars of grant and also IBRD loan to Ukraine in the energy sector to restore those damaged equipment, particularly, as I said, transmission facilities and also hydropower plants. And then on the analytical and advisory aspects, through technical assistance, we have been also supporting a little bit longer term, from the longer term perspective for the reform and restoration of the sector. And one of which is power system resilience with the support from GFDRR. So the question is how the power system resilience can be strengthened. There are two elements. On the planning side, there are lots of measures can be done. Of course, stronger material, of course, underground distribution transmission network could be an option, although it's very expensive. And also, the utilities have to manage vegetations under transmission lines. And relocate some facilities located in hazard areas can be also option. And also, from the system perspective, maybe the system has to have sufficient reserves to mitigate the impacts caused by loss of one element or two elements. And definitely distributed energy resources is an option to make the system more resilient. On the operation side, we have, of course, the more accurate forecast based on the weather forecast, and visualization of the system is also one of the element. And for the planning side, network configuration can be also improved, and advanced protection. And also the demand side, if we lose one generation plant, generation side, we can also, it should be, control the demand to mitigate, to ensure the power system supply and the demand balance. And repair crew mobilization, institutional preparedness for such events also critical. And maybe emergency generation can be also mobilized as well. So with the GFDR support, we have conducted some analysis and capacity building on the power system resilience. We have analyzed specific technologies, measures, that can help strengthen the power system resilience, which is, as I said, the demand response, and the dynamic line rating, which helps TSO to tentatively increase the power system capacity, transmission network capacity. And the drone is also a very strong tool to detect the location of the damages and also to restore the facilities. And we also organized a study trip to Japan to exchange knowledge with the Japanese counterparts. particularly utilities, of course, and the ministry on the policy level. We visited also hydrogen site as well. So it was yeah, quite interesting and useful for Ukrainian counterparts. One concrete example is that the visit to underground substation located in Kobe. So of course in Kobe, the utility built this underground substation due to the, area constraint. So it's totally different motivation, but the Ukrainian also colleagues have learned and also wants to implement this to protect the substation to make this substation to be underground. So they are constructing such very significant measures to protect the electricity facilities. So this is conclusion. So we have been supporting Ukraine, and there are, as I said, very similarity with the natural and climate disasters. And diversification and decentralization also very important. It's not only the answer, but this is also very important to enhance the power system resilience. And the GFDRR has been very instrumental for Ukraine to meet this goal. So I think, that's all my presentation. I think I will pass the floor to Oleg now. He's a Chief Investment Officer from Ukrenergo, the transmission system operator. So he can talk about more on the actual damages caused by military attacks. So can you switch to team? ティームに切り替えてもらっていいですか? So Oleg, can you hear me?
Yes, Koji.
Yeah, thank you. So the floor is yours.
Yes, thank you very much. Good afternoon, ladies and gentlemen. And first of all, thank you very much for all the support that has been rendered to Ukraine, which is very crucial to keep the lights on here. So let me give you the demonstration. I'm not sure if it's now on your screen. Probably not yet. Nevertheless, let me start with saying that in 2022 and 2023, Ukraine's energy workers did the impossible. We preserved and managed to overcome the consequences of dozens waves of massive missile and drone attacks against energy infrastructure, an unprecedented event in the world's history. However, if not destroyed to the ground, Russian terrorism continues its cruel pace, and this is exactly what is happening in Ukraine right now. Since the beginning of this year, Ukraine's power system suffered from 6 massive combined cruise and ballistic missile and drone attacks. As a result, around 100 of missiles of that type and 80 kamikaze drones hit energy infrastructure facilities all across Ukraine. This year, in addition to strikes against the electricity transmission infrastructure, the enemy focused its attacks on generation facilities as well. Practically all thermal and hydropower plants, which constitute the main part of the country's maneuvering capacities, were either damaged or completely destroyed. As a result of recent Russian attacks, the share of generation from thermal power plants in total electricity production decreased from 30% to less than 5%. Nearly 40% of all generating capacities that were available in Ukraine's power system were destroyed or brought out of operation due to that damage. This is an appalling figure for the country, with the population of more than 30 million people. Considering a significant deficit in generation capacities within the system, Ukrenergo's dispatch center is forced now to restrict the usual consumption. As of now, consumption restrictions for households and businesses are applied in all regions of Ukraine without any exception on a daily basis. Next slide, please. On these slides, you might see the demonstration of what the damage looks like. Unfortunately, the upcoming winter heating season will be even more challenging for Ukraine. Thermal power plants, hydropower plants, high voltage equipment for transmission, all of that has been damaged, and this is 21st century center of Europe. But almost everything is destroyed now by Russian war criminals. Next slide, please. Here you can see the damage inflicted to hydropower plants. And on the next slide, please, you will also see what damage looks like when it comes to transmission grid. Next slide, please. So given the current state of affairs, Ukrenergo is once again on the verge of being in need of help. So what we would be needing should the attacks against energy infrastructure, specifically transmission grid, continue, would be the equipment which is normally used on our substations, like auto transformers, circuit breakers, disconnectors, open and gas insulated switchgear, relay protection, and other high voltage equipment. Thanks to the support from our international partners and from the World Bank specifically, we have purchased the majority of the items that we have lost over the past 2 years. But we perfectly understand that the enemy will keep on their attempts to shut the light off in the whole country. So as can be seen from various strategies of Russian attacks, the vulnerability of a power system is basically in its two main components. First, of course, is the transmission grid, which can be shut down by destroying sufficient number of auto transformers. And it doesn't even take to destroy the whole substation. Auto transformer is enough. These units are crucial for operation of substation, and desired effect can be achieved by the enemy when those are destroyed on substations that provide for power output of major generation units, such as nuclear power plants. Moreover, it is worth mentioning that no transmission system operator globally has a fleet of reserve auto transformers to swiftly replace them. And we all know that lead times nowadays do not allow for fast recovery. However, there are physical protection solutions, application of which can resolve the issue of drone attacks. Obviously, of course, this relates to outdoor substations. Those ones which are built underground have that necessary inherent level of protection. Combined with strong air defense systems against missiles, transmission grid can stay, therefore, resilient enough. But the second category is generation units. Weakness here lies in having dozen or two big generation units that cover largest part of the consumption. Such big generation units cannot be physically protected with only air defense standing to guard them. As demonstrated by Ukrainian experience, generation shall be mainly distributed so that there is possibility to physically protect it. In addition, it is nearly impossible to destroy, for example, 200 small thermal units of, say, 10 megawatt capacity each, as long as they are scattered around the country. On contrary, it might take just 5-7 ballistic missiles to bring the 2 gigawatt thermal power plant to zero, as was the case in Ukraine. And this is why Russian terrorism must cease to exist. This is why all the countries respecting the principle of international law must unite to stop the aggressor and prevent any possible humanitarian catastrophe in the future. I would like once again to thank Japan and people of Japan for the support. We're all grateful here, and once again, thank you very much.
Thank you, Oleg and Koji, for sharing those lessons from Ukraine. I think, we'll agree that the nature of shocks that Ukraine is facing is different from some of the most of the conversations we're having in understanding risk, but definitely some of the lessons applied to in the electricity sector. I think we heard from those aspects of identifying the most critical components and also the importance of redundancy for adding to the resilience. With that, I want to invite our last speaker. He's the General Manager on Asset Management in the Kansai Electric Power Company, Mr. Takayuki Doi. And he will share some of the knowledge from that Japan has in the sector. Taka-san, over to you.
Good afternoon. I'm Takayuki Doi. Currently, I'm working for the Kansai Electric Power, which is one of the Japanese utilities. But I used to work for the World Bank, and then at that time, my job was to recommend capital investment to my client country, and basically assist them get loans from the bank. That's what I used to do. But today, I'm talking about disaster risk management without capital investment. I'm not trying to say what I used to do was wrong. I still believe capital investment is absolutely necessary to tackle with disaster. But I try to propose today is that there's some steps to make capital investment even more effective. Let me talk a little bit about Kansai Electric. If you look at the left side, there are 10 Japanese utilities, and Tokyo Electric is the largest, and the Kansai is the second largest in Japan. The Kansai covers the area, Kansai area, including Osaka, Kyoto, Kobe, and even Himeji here. So yeah, I would like to appreciate the organizer to use our electricity for this event. And then please take a look at the right side, and this is overview of Kansai system. Our system includes hydropower, solar, wind, thermal power plants in Himeji area, and also nuclear power plants. It's quite diversified. This kind of diversity of the power plants also enhance our disaster resilience. Then if Japanese power utilities are asked about their disaster risk management, a lot of examples would be provided. For example, as one example of prevention, Kansai Electric constructed 8-meter tall seawalls around the nuclear power plant to prevent any kind of impact that can caused by tsunami. This is in response to what happened at the Tokyo Electric's Fukushima power plant in 2011. And then mitigation example in the middle. In some areas, we use flexible joint for the underground transmission pipes to mitigate the damage caused by earthquakes. And on the right side, whenever we have facility damage, we try to aim to build back better. In this example, an old hydropower plant was destroyed due to river flooding, but it was rebuilt on the elevated ground so that the river flooding of the same level wouldn't affect this power plant anymore. These capital investments are quite effective, but should these investments be applied in other countries? Because this is quite locational issue, and also the capital investment on the previous slide are very effective, and also other example on the below, such as making power networks redundant, undergrounding of power lines, deploying bucket trucks to all locations. They are all effective, but they require a lot of investment. Let's take a look at how many disasters occurring in Japan. We have 24 typhoons a year, quite a lot. But more surprisingly, we have 330 earthquakes a year. So almost every day, somewhere we have earthquake. So we are quite used to earthquake. So even if we have earthquake here right now, those who are living in Japan wouldn't be surprised that much. But we don't have blackout at all. I mean, most of people have never experienced blackout. So if they experience blackout, they would be very surprised here. And then tsunamis, this is not very often, but this happens every 10 years. So we need to prepare for this kind of event, especially for the critical facilities. So given this kind of statistics, it is spending huge budget for disaster risk management in Japan economically and ethically makes sense. But in the real world, budget always has some certain limit, and also we need to weigh up cost and benefit depending on the situation. And also for that purpose, we need to identify which kind of investment should be prioritized. For that purpose, I'd like to propose disaster risk management without capital investment as the first step. Even without capital investment, we can develop a disaster response plan to enable swift response. We can also build the collaboration framework with neighboring utilities to share our resources and also to avoid redundant investments. And also conducting regular drills improve response skills and also enhance readiness for the disaster. These no capital investment measures are also quite effective and very cost effective because there's no capital expenditure. In addition, starting with this kind of measure can identify what is lacking and also what kind of measures is truly cost effective. Conclusion, capital investments matter. So in the end, capital investment is necessary to tackle with certain events. In our case, for example, Kansai constructed 8-meter tall walls around the nuclear power plant. It was absolutely necessary because we cannot allow what happened at Fukushima to happen at our power plant. But the insights based on our experience, before using huge budget, it's also recommendable to start with strategic planning, collaboration, and training. And the expected impact, such an approach promotes organizational awareness, ensures optimal allocation, and in the long run, significantly boosts overall resilience. This concludes my presentation. Thank you very much.
Thank you very much. I think that definitely that message of that reminding us that there are effective measures that help to contribute to resilience that do not necessarily need capital investment is that something to keep in mind. So now we're going to move into the questions and answers, and also we want to invite the audience if you also have some insights on risk assessment in the sector or solutions, please do also, if you want to share your insights. We know understanding risks brings the people from the insurance industry, solutions providers, academia. So we're also interested in hearing from your insights. For that part of this session, I'm going to invite the speakers in person to join me here up front. So Taka, Koji, and Mansoul. And also want to check that, Oleg, can you hear us well?
Yes, the connection is good. Thank you.
Perfect. Thank you very much. I want to make sure that you can hear the questions from the audience. So what I'll ask is that if you have any questions, please raise your hand. I'll bring the microphone to you, or if you can help us, please. So we can, and then please, when you speak, introduce yourself and your affiliation, so the speakers can know who you are, and everyone else here can know who you are. So do we have any questions in the audience? No?
Thanks. My name is Paolo Manunta, Asian Development Bank. I have a question for Manzul. Of course, like that was very easy presentation to read, understand the risk in Bangladesh. As you know, we work a lot in Bangladesh. But what is the next step? Because I understand that you pointed out that probably there's an extra step to be done. And the question is actually of two kinds. What kind of extra step is needed? And are you planning to do something more specific for single sites and also transmission lines?
Okay, so I think this particular work, we are asked to do the risk assessment. But when I look at all the documents, so basically, I think World Bank probably take next step to provide financial support to make this power system more resilient to cyclone and flood. So what I see is that how to do that is a lot of capital investment will be required, and one of the thing is probably the power plants which are near to the river where flooding is very frequent. So I think some kind of flood mitigation measures could be taken there. And another big problem actually is also a lot of river erosion in Bangladesh, and some of the locations it could be several kilometers wide river, right? So that is also one thing we are looking into. Some of the power points near the river that could be in future, it might be eroded. So some of the river protection measures could be taken. And for wind, in these documents which I have read is that if some of these power lines or area is very affected by in future very high speed hurricanes or tropical cyclone, they could think of make them underground in those locations. So depending on the location and these particular three hazards, cyclone, flood, and river erosion. I think these are the major issues. But in addition to that, they are also looking at asking us to see what is the temperature and humidity next 50 years, 100 years, because that also affect the efficiency of the power line. So that can be that kind of high temperature, the demand is very high, high temperature situation. So some of the measures could be taken in that direction. But detailed documentation I don't have. Maybe World Bank, they have a plan for maybe another technical assistance or loan or something like that. They have some plan, I think. Thank you.
Thank you very much. Do we have any other questions or comments from the audience? No. Okay. Well, I do have a question, and maybe I'll start asking this question to Oleg, and then I'll ask Taka to add to that question from the expertise in Japan. Is we heard from Koji that diversification and decentralization are critical to enhance the power system resilience, right? But we also know that that changes a lot of the norm on how to deliver on the standards or reliability of the power system. So my question to you, Oleg, and then Taka, is if you can share some of the solutions for power system resilience in that context of when we have a system with more of that decentralized generation of how to keep that reliability also even in the context of shocks, and how much does that change it in the context of decentralized generation?
Yes, thank you very much for this question. Actually, we at Ukrenergo have analyzed what specifically can be done in the, I would say, short and midterm perspective to make a swift transition towards this decentralized generation. Of course, we understand this is not only about construction. There are certain market rules which have to be introduced so that there is a big interest from private investors to come invest and build new generation facilities. Although we've gone further and we have analyzed, I would say, 3 major technologies which would be focused on the resource vastly available in Ukraine, which therefore is very crucial to be considered. These are basically 3 major investment profiles. I'll be glad to share the presentation afterwards, giving a description of every category of such investment, demonstrating their investment attractiveness by showing the CapEx, the OpEx, also IRRs and other economic parameters, which should be considered by private investors before stepping in. We believe, of course, that the proportion or the overall capacity which should come to Ukraine is basically equivalent to whatever generation capacity has been lost. Although we understand this is not achievable to our deep regret by the winter which is now to come. Therefore, this strategy will be covering a couple of years, year of 2025 and 2026. In the meantime, the energy system has also to take all the necessary actions to repair whatever units can still be repaired and obviously provide for their air defense protection, as there is no other ways of providing for physical protection. So let me share with you afterwards the presentation. I believe it will be useful. The presentation, apart from 3 major project profiles, will also contain the map where such generation facilities can be built based on the availability of the grid and of the respective resource which has to be used for generation of electricity. Thank you.
Thank you very much, Oleg and Taka. Yes.
Thank you for the question. And then let me explain diversification and decentralization separately. Diversification is definitely effective. This is not only for power sector. In any actions, like even stock market investments, diversified portfolio is quite good to mitigate risk. And then in power sector, diversified generation resources, that's also effective. In Japan, for example, if we rely on a single type of power source, then one single supply chain can cause like a large-scale blackout. So diversification is definitely effective. But in case of decentralization, it has pros and cons. And then from the power engineering perspective, especially spread out small generators like solar power, it can be effective, but in some cases, it cannot hold the power system stable because the power system requires constant balancing between demand and supply. And the microgrid with solar power alone cannot fulfill such requirement. Having said that, combining with energy storage, even solar power can sustain the power grid. And then energy storage is very expensive, but once the electric vehicles are commonplace and also vehicle-to-grid technology advanced, then combining those technologies, probably solar power can be quite important tool to enhance resilience. That's the comment from my experience. Back to you.
Thank you very much. So I gather from your answers that it's also a question of thinking strategically about also the location, but also we need some additional measures to make sure that the reliability and stability of the network can be sustained. And then my last question, I think, is for Koji, unless I see any other follow-up questions from the audience. Hands raised? No? Oh, yes. Okay. Then please.
Hi, I'm an urban specialist with the World Bank. My name is Devashri. I'm accompanying actually the Ukrainian delegation that's working on housing. But it's a really interesting idea about holding off on immediate capital expenditure and just taking that idea to Ukraine, where so many people have left the country and we don't know whether they'll come back, and there's a sectoral transformation, businesses are moving out. We don't know whether they'll relocate at the same place that they were earlier. The manufacturing sector is moving from east, away from the east to other regions. So in that light, how are you strategically planning or projecting where the needs will be when you think about, you know, repairing or investing more in rebuilding all of these energy-related infrastructure? And are there any lessons that other utility sectors in Ukraine can learn from it at this point? And this question is to, I guess, everyone on the panel.
Thank you very much. So maybe maybe we start with Oleg. Yeah, and then Koji will add to that answer. Oleg. Oleg, can you hear us? Okay, so maybe we've lost the connection, so Koji, please.
This is great question. So in terms of the demand, electricity demand, it's decreased by 30%. I mean, before compared with the pre-war situation because of the temporary relocation, and also some industries also stopped the consumption. But in the west side of Ukraine, like Lviv, there is increased demand. So there should be some locational, regional analysis on the electricity needs and for restoration, reconstruction. And also electricity payment rate also, decreased in the eastern side because people are not in the house. So, but in the west, it's, kept as 100% almost. So there are some strategic elements. And also on the supply side, the generation side, as Oleg said, diversification, but in the context of Ukraine, it's more on not through renewable energy because solar and wind doesn't help much in this situation, so more on the gas generators. But it takes also time to manufacture such equipment, and particularly for large power plant, it's very difficult to restore the large power plant in the short term. So some level of decentralization helps, but in the meanwhile, it's not like off-grid separated grid, but it's still large power system is necessary to complement such electricity supply. And also Ukraine is already connected with the European power grid. It started immediately after the start of the war. So Ukraine is now importing electricity quite significant amount, which also helps. And also one element is that demand, as Oleg said, overall demand is significantly decreased. So there is some, there used to be some generation surplus now, but due to the recent attacks on the hydropower plants and the thermal power plants, the situation is different. The current situation is better in terms of the season, but for the upcoming winter, it's very difficult. So there is some exercise for the long-term planning from the perspective for the long term, and also standardization may be needed, and also in line with the European standards. Because all systems, all facilities are designed in the Soviet design standards. So it's also important to strategically thinking. We are also helping Ministry of Energy to have such long-term planning. Also, considering also, of course, clean energy transition as well. So there is some, discussions ongoing, but it's very, now the situation is also, dramatically changing. So the baseline, the worst case we thought is now base case, so the next winter would be very difficult.
Thank you, Koji. Mansoor, I see you want to add to that.
Not respond to this question, but I just have a little bit of curiosity about our Dr. Doi-san. Regarding this nuclear power plant you have, and you are protecting those from tsunami. After your Fukushima, what happened, I was always thinking, why we have to have, we know that the nuclear plant needs a lot of water. But it does not mean that we put that nuclear plant just in the shore within a few 100 meters. Why don't you put in 5 kilometers away and pump the water from the sea and take up water, whatever required? Why it hasn't done that way? Is there any reason for that putting in the exactly in the shore? Yeah.
Thank you. Thank you very much for the question. So to take out the water from the plant side to the outside the sea, we need to use a pump. Pump requires electricity. And what Fukushima happened is that they have some small generators, but because of tsunami, it made like unfunctional. So in any case, we need some facilities that requires electricity, and then without that facility, we cannot take out anything, like water, etc. So that's why we need to protect the area by walls first, so that we can do everything with some maintained electricity and facilities.
What I'm saying is, suppose you are building a new nuclear power plant. Why don't you make it in 5 kilometers inside the land rather than in the next to the sea? Is it possible? Is it a good idea? Few kilometers inside.
Yeah, actually, technically, it's a good idea, but this is not more like nuclear power is not only technical issue, right? Because we need to get acceptance from the people who are living there, and then so there's no. Basically, we already use the best location for nuclear power across the sea, so that's why we sometimes need to choose, some realistic location.
Okay, thank you.
Thank you very much. You want to add? Okay.
I think one element unique in Japan is the river is not like a big river in Bangladesh, maybe Europe, and the nuclear power plants are located inside the land, but still near the river. The river here is a bit different. It's steep and it's not, for transportation. And then flooding could be also accelerated inside the river. So I think it's a little bit geographically it's constrained in Japan. Only option should be very close to the coastal area.
Thank you very much. Thank you for that additional discussion. I know that it's the end of the day, and I'm sure we're all tired, maybe already making plans for dinner. So we're going to wrap up the discussion. If anyone has any other questions for our speakers, we're here to connect, and at least I know Koji and Mansoor will be around tomorrow and Thursday. If you have any other questions for them, please connect with them. So thank you to our speakers. Thank you to all of you for participating. Thank you, Oleg, for connecting online. And I think that definitely here we discuss how the case from Ukraine underscores the importance of the power system for the resilience of the communities and the economy. And in that way, it highlights the importance of better understanding that risk and identifying the measures to address that risk to the power system. And I hope that this session motivates everyone to work with us, with the World Bank Energy Unit, with the GFDR, on towards a more systematic risk understanding in the sector, and also identifying solutions for investments in the power sector. So thank you very much, and I hope you have a nice evening.